Let's start with page 17. Number 6 says let f be the function given by x minus 4 quantity squared, and let g be the function given by g of x equal to e to the 2x, sorry, e to the 3x. At what value does the graph have tangent lines that are perpendicular? So we know that anything dealing with slope, we got to be dealing with derivative. But we want to figure out where these have opposite reciprocal slopes. So if it's parallel, then we can just set the derivatives equal to each other. But if it's perpendicular, we're going to set their reciprocal derivatives equal to each other. So we're going to find f prime. We're going to find g prime. But we're going to create this scenario here. Because we know that slopes are perpendicular if they're opposite reciprocal. So for instance, if I have slope of negative 1/3 and a slope of 3, then we know that these two are going to create 90-degree angles because opposite reciprocal. Yeah, so that's what we're going to do to start off. But either way, we're going to have to get to our g prime and f prime before we do anything else. Okay, so let's do one derivative at a time. Okay, so f prime first. We can go through chain rule here. Outside times inside's derivative. So bring down the 2, keep the parentheses, subtract 1 from the exponent, multiply by the inside function derivative. Okay, so there's my f prime. Okay, g prime. We know g is e to the 3x. So g prime, e to the u times u prime. So e to the u times u prime. So we're going to set them equal to each other in this relationship here. So here's my f prime, 2x minus 8. If I distribute that 2 through. Here's my reciprocal of my g prime. Now, it's going to be hard to solve this by hand. So this is where we can use our calculator. Why don't we just bring everything over to one side, graph that function, and look for the x-intercept. Anytime, we don't want to solve this by hand. So let me bring this over to one side. Get that 0 to show up. And now it's as straightforward as graphing this. And then just look for the x-intercept. And it's nice having our answer choices here because we know that everything that we're looking for has to be between -2 and 2 or -1 and 1. So when we graph this, we can just set our window to those locations because we know it's got to, those are the only choices that we're looking at, right? So here's y1. I have 2x minus 8 plus, I'll do alpha y equals to get that fraction there. 1 over 3 e. E is inside natural log there, ln there. E to the 3x. Okay, we're going to graph this. If you want, you can start with zoom 6. we know we're probably looking at that value there. So let me just adjust my window here. I just need to see from -2 to 2. And maybe I don't, yeah, maybe I don't have to get all the way up to -10. I'm just I like to play around with these numbers here just to make it a little easier to read here. Okay, so that's the x-intercept I'm looking for. So do second trace, 0. We're looking for an x-intercept. Pick a point to the left of the x-intercept. For the cursor, there it is. Hit enter once, and then move over to the other side of the x-intercept, hit enter again, hit enter a third time, -1.143. There's my solution. Okay, we did 7 in class yesterday, right? Just chain rule. Any questions? All right, number 8 is a derivative inverse at a point. This is where we go through that chart going around that quadrant there. So yeah, let me create my little quadrant here. I know I'm trying to find the derivative of f inverse at 2. I know 2 is the x value of my inverse. That's what I'm looking for at the end. And I know that because 2 is the x value of my inverse, 2 must be the what of my function. The y, yep. So I know that this is how I can begin my problem. Okay, so this is a little bit working backwards here because we know what the y value is. So we're going to insert that 2 in for the y location. And we're going to have to do a little bit of guess and check to figure out what the x is. And once we can figure out the x, then everything can be done on the function side. And then once we find that slope, we can flip it to get the actual answer we're looking for. Okay, we'll bring everything over to one side here. I'm going to go through a series of guess and check. It should be an easy number to find. It should be a number that's close to 0. So if I try 0, 0 doesn't work. If I try, well, because 0 plus 0 minus 2, -2 doesn't equal to 0, doesn't work. If I try 1, does 1 work? 1 plus 1 is 2, 2 minus 2 is 0, so 1 works. So if 1 doesn't work, then try -1. If -1 doesn't work, then try 2 and -2. After a few tries, we should be able to find that number. So we have our x value. So we know there's order pair 1, 2, which must mean there's an order pair 2, 1. So if I can find f prime of 1, then this slope value will lead me to that slope. I know that there's going to be a reciprocal relationship there. Okay, so before I can find f prime of 1, I first have to find f prime of x. Find f prime of x. What's the derivative here? X to the 5th becomes what? X becomes 1. Okay, so there's my slope formula. I'm going to plug 1 in to find the slope. 5 plus 1 is 6. So if there's a slope of steepness of 6, on the inverse side, at its corresponding point, there must be a slope of what? 1/6, yeah. There's always going to be that reciprocal relationship there. So we're not touching anything on the inverse side. We're doing everything on the function side, and then using that data to flip back over to the inverse. Okay, number 9, graph of a function is shown. Let h be defined as x plus 1 times f of x. Find h prime. So I have to get to h prime. I have to get to h prime. Sorry, to get to h prime of 4, I have to get to h prime of x. Get to h prime of x. Look at how my h is designed here. I have to go through what to get to my derivative. Anything stand out about how h is structured? Product rule. Yeah, you see x plus 1. The giveaway is that times there. Right? Anytime I'm multiplying anything together and I'm trying to deal with derivative, I got to go through product rule. Okay, so f prime g plus f g prime. You write h again. Okay, x plus 1's derivative is just going to be 1. G, no changes. F, no changes. And g prime, turn that into a derivative. Okay, replace every x with 4. So we want to use the graph to help us find f of 4. F of 4 is just the y value. So what's that y value? Just 4, right? Okay, so f prime of 4, that's asking for the what at this point? Slope, right? And what's the steepness of this line? -2, right? I pick any point on this graph and I just do rise over run. I go down 2 over 1, that's -2 slope. So 4 minus 10, -6. Yeah.
On number 6, does it matter which index you do? Can do either one.
Yeah, you can do either one.
Okay.
I just found it easier to flip the single value rather than flipping that. But yeah, you can flip that and you'll get the same thing. You can try it. You can shoot it. Okay, number 10, page 18. Okay, a spherical balloon is inflated at a rate of 3 cubic inches per second. You see time involved here. It's like a word problem. You know, it's going to be related rates. Determine the rate of change of the radius of the balloon when the balloon's radius is 5 inches. The volume of the sphere of radius r is 4/3 pi r cubed. Okay, so we have our volume formula. We know we have to find the derivative. We know d over dt will begin showing up. Let's just get that calculus portion out of the way. So every variable gets impacted by time. We find the variable's derivative, and then we attach d over dt. So v becomes 1 dv dt. We bring the 3 down, do the coefficients. So 4/3 pi, that's a coefficient that's not going to go anywhere. R cubed becomes 3r squared. R. We do a little bit of cleanup here. It looks like the 3's can just cancel out. Just trying to clean it up so there's less numbers to plug in later. All right, let's gather some information here. Balloon is being inflated at a rate of 3 cubic inches per second. What do you think that number is referring to? What variable is that referring to? dV over dt, right? You see cubic inches, you know it's got to be volume related. It's got to have a time component. So volume and time, the only thing with both those things is dV dt. Positive or negative? Positive. Determine the rate of change of the radius of the balloon. What are we looking for? dr dt, right? You see the rate of change. We're not looking for just r, we're looking for dr dt. That's the unknown. When the balloon's radius is 5 inches. Okay, so r equals 5. So everything should be pretty straightforward now. Just plug everything in. We're looking for dr dt. We have r, we have dv dt, so every variable is accounted for. Now we're just trying to get it down to a number. Twenty-five times 4 is 100. So I have 3 divided by 100 pi. Plug that in the calculator. We'll get 0.0095, which can round to 0.010. Okay, we're talking about radius here. So we know radius is a one-dimensional unit, so inches per second. Oh, you're asking, do we always have time involved?
Yeah.
If it's related rates, we do. And we know it's related rates because you see the problem has mentions of time. Right? So anytime there's a mention of time and you're given an equation, that's when we know that there's going to be.
We change the equation first.
Find the what?
Like you change the volume equation first.
Yeah, that's what I like to do. I like to just get that derivative out of the way so I can see all the variables that I'm needing to work with, and then I gather information and I plug in. That's what I prefer to do.
Okay.
Yeah, if it's same on AP exam. Uh, I think the only thing that you're expected to know on the AP exam in terms of geometric formulas are rectangles, trapezoids, triangles, circles, but everything else they'll give you. Okay, everybody good? All right, number 11. We have a function sine of x over 2. There exists a number such that mean value theorem can be satisfied. So mean value theorem is basically saying set the average rate of change equal to the instantaneous rate of change. So what I mean by that is you find the slope between the endpoints, you set it equal to the derivative, and that's it. So I like to get the messy part out of the way, which is just the algebra portion. So we're just going to find the endpoints, find the y values, find the order pairs, and find the slope between the endpoints, and then we can do the derivative. So slope between the endpoints, we want to find f of pi over 2. And we want to find f of 3 pi over 2. But let's do pi over 2 first. I'm going to replace x with pi over 2. So that's really pi over 2, which is really sine of pi over 4, which is root 2 over 2, right? Unit circle value. Sine of 3 pi over 2. That's going to be sine of 3 pi over 2 divided by 2, which is going to end up being 3 pi over 4.
In the calculator, when it gives you a decimal, how can you change it to make it for what one, like how do you make it?
Yeah, the calculator, I don't think can do the conversion to, but here are some nice things to know. 0.866 is √3/2. 0.707 is √2/2. You know, 1/2 is 0.5. And these are the most common ones. I think it's a good reminder too, that when we get closer to the AP exam, that you're looking through and your unit circle value. I'm letting you use your calculator, but this is meant to be a non-calculator question, right? So I want to make sure that we can, obviously, I want to give you that calculator to help you, give you a safety net, but okay, so sine of 3 pi/4, you know that this is in the second quadrant, but sine is still positive, so still positive √2/2. Okay, so let's find the slope between the endpoints, right? So change in y over change in x. Okay, what does the numerator give us? 0. That's nice. So you know that anything over 0 is just going to be 0. Number 2 is going to be pi. So that's the slope that we're trying to guarantee. Basically, it's going to be a Rolle's theorem, but they don't have to mention Rolle's theorem, because Rolle's theorem is just a very specific subset of mean value theorem. It just happens to be 0. So now we can find the derivative and set equal to this number. Okay, so to find the derivative, we have to go through what? Sine of u becomes what? Yeah, cosine of u times u prime. So if we think of f of x as sine of 1/2 x, f prime is just cosine of 1/2 x times 1/2, right? Cosine of u times u prime. So all we're doing with mean value theorem is we take the derivative, we take the slope between the endpoints, and we set them equal to each other. So basically what it's saying is that because the slope between the endpoints is 0, there must be a place on the curve where the slope is exactly 0. And then this is what we can do. Mean value theorem can help us find that location where this guaranteed slope is going to occur. So if we divide by 1/2, we can make that go away. So that 1/2 just goes away. So cosine of 1/2 x equals 0. If we go through inverse, we can say 1/2 x equals inverse cosine of 0. So in other words, this is asking, where is cosine going to be 0? I'm going to list out some values for cosine of 0. Cosine of 0 at pi/2, at 3 pi/2. I keep going, 5 pi/2, and I can set that equal to 1/2 x. And then to solve for x, I can multiply everything through by 2. So x equals pi, 3 pi, and 5 pi. And the only answer choice that I see that matches is pi, so answer choice D. Okay, 12, the derivative is given on what interval is our f of x decreasing. So this is a calculator question where we graph f prime and we interpret the derivative graph and create our slope sine line and look at the arrows and see where our arrows is pointing down. So all this goes in the calculator. It tells you between 0 and 9, so gives you interval to work with. Okay, e to the sine of x minus cosine of x minus 1. I'll just do zoom 6. Actually, I only look at what's between 0 and 9 here. So let me adjust my window here. let's go from 0 to 10. I don't have to show all of these here, so. So I'm going to find those x-intercepts, understand that anything above the x-axis is a positive slope, below the x-axis is a negative slope, so I'm going to find those 3 x-intercepts. Second trace, 0, and I'm going to just start with the furthest left x-intercept. Okay, I get 0.633. Keep going. Find my second x-intercept. Point 4.115. Keep going. Second trace 0. First x-intercept. Second x-intercept. 6.915. Okay, so 6.916. So if I have those x-intercepts identified, and I know that I'm starting below, moving above, I'm going to translate those arrows onto my slope sign line. And now I'm going to look at these arrows. These arrows is indicating how the actual graph is moving. So we can expect a relative min here, a relative max, a relative min, and then we have 2 intervals of decrease from 0 to 0.63, and then 4.15 to 6.9. Okay, 13. Sorry, any questions with 12? Okay, let me redo 13 because it's not written in a way that that you're gonna see it. This is a little bit more complicated than they need to make it. So let me give a different set. Or different let me change it a little bit. This is worded more difficult here. So let me write it this way here. So 13, same equation here. We're going to build a tangent line approximation, linear approximation at x equals 0. So we're going to find our order pair, find our slope, point slope form, build that tangent line, and then we're going to use the decimal negative 0.05 to insert into our tangent line equation. Right. So first things first, let's gather our order pair. So plug 0 in for x. So 0 in for x. What do we get? What's the y give us? If 0, what's my order pair? If x is 0, then my y value is what? Yeah, it's just 1 plus 0, which is square root of 1, which is 1. Okay, so there's my order pairs, 0, 1. To find my slope, I got to get to my derivative. To get to my derivative, I got to go through a little bit of what? What's involved here if I want to find the derivative? Outside, inside, so what? Chain rule, yep. So outside derivative, f prime. take care of that 1/2. So 1/2 parentheses to the negative 1/2. Keep the inside intact. Then in a different space, we'll multiply by the inside function's derivative. So 1 plus x becomes 1. So there's our derivative. Okay, so from our derivative, we can find our slope. Let me clean this up a little bit here. So f prime 1 over 2, 1 plus x to the 1. Okay, plug 0 in for x to find the slope at that point. Okay, what does that clean up to be? 1 to the 1/2 is still what? Still 1, right? So my slope is just 1/2. All right, so let's build our tangent line equation, right? We have our point, we have our slope. Now point slope form. Let me get y by itself. So now that I have my tangent line equation, my final step is to insert that decimal. So basically, that's the easiest part of the problem, just plugging in. But all your work is basically your tangent line equation, right? Sorry, my key is wrong because I was working a different problem, but it would be also worded more straightforward like this, where you're given a clear location to build your tangent line, and then you're given a clear decimal to plug in. Uh, okay, there's a specific problem I want to go over with you. Give me 1 second. The question is, what values of the real constants of A and B can make the function differentiable everywhere? So we know there's a piecewise function here. Piecewise function, differentiable means what? Means slope exists, right? That means the graph is going to be not only connected, but it's got to be a smooth curve. So there's something about this, about -1 that has to be fulfilled. Both of these expressions have to share the same what at -1? Good, because it's continuous, right? It's got to be continuous. So they must share the same y value at x equals -1. Okay? And then they also must share the same what? Slope. So shares the same slope. So because they share the same y value, we can set these equal to each other, right? So that makes sense that they must connect at -1. So I can say x squared plus 2b is equal to ax plus b. And we know that the location that they must share the same y values at x equals -1, replace every x with -1, we get 1 squared, which is 1, plus 2b is equal to a times -1, which is -a, plus b. All right, I'm going to leave this alone for now. We'll come back to it. They must share the same slope as well. So if they share the same slope, because the word differentiable, that means, these two graphs at -1, not only are they going to connect, they're going to connect in a way where there's going to be a smooth transition from one graph to the next, where it's not going to be a sudden sharp turn. So if they share the same slope, what can we set also equal to each other? The derivatives, right? Now, when you find the derivative of a and b, think of those as numbers, right? Imagine this is x squared plus 2x, or sorry, x squared plus 2 times 3, and then 5x plus 6, something like that. Okay. So keep in mind that a's and b's are numbers and not variables. So what's the derivative of x squared plus 2b? 2x. What happens to the 2b? 0. Okay. So set derivatives equal. Okay. Ax plus b. What's ax plus b's derivative? Just a. Imagine this is 3x plus 4, right? If it was 3x plus 4, you would say 3 plus 0. Same thing. Ax plus b would just be a plus 0, which is a. Okay. So where do they share the same slope? At what? X equals. What location do they share the same slope? What x value location, though? Yeah, -1, right? Everything that we're talking about is at -1. So I can replace x with what? -1. So 2 times -1. So I know what my a value is. A is -2. Can I figure out what my b value is? There's something available to help me find the b value. This equation, right? We have this worked out halfway. So let's see if we can finish it. Replace a with -2. So negative times -2 will give me what? Positive 2. So 1 plus 2b is equal to 2 plus b. 2b minus b is just going to be 1b. 2 minus 1 is just 1. So b equals. So you see that word differentiable, just understand with piecewise function, you can create two categories. There's the continuous equation that we can create. We can set the equations equal to each other. We can also set the derivatives equal to each other. And then we can use both equations to help each other to find our missing information.
Or whatever, say something else besides this.
No, it'll be written like this. Okay, so again, the topics that you are responsible for today's quiz, or sorry, test, continuity, L'Hopital's rule, derivatives and slope concepts, product rule, chain rule, quotient rule, implicit differentiation, related rates, you can interpret a derivative graph, curve sketching, such as using first order test, test concavity, calculated problems, linear approximation, particle motion, like position to velocity to acceleration, theorems such as EVT and mean value theorem, trig derivatives, natural log derivatives, natural log properties, derivative inverse by the point. So I think we've been kind of cycling through these concepts. Right? Okay. Any questions? Any problems you want me to redo with you between 1 through 8 and 13 through 18? Yeah. Mm-hmm. Yeah, let's see. I did number 8. You want me to do number 8 again? This one here? Or this is 8 on page 17. Were you here when I just did that? Okay, all right, so I do this over again. So here, there's inverse at a point. The idea is that there's a certain relationship between the function and the inverse. And what we know is that ultimately I'm looking for this bottom quadrant here. I'm trying to find the derivative of f inverse at 2. Now, 2 is the x value of my inverse function, which must mean that 2 is the what of my function. Y value. So I know this to be true even without looking at the rest of my problem. So my first goal is to figure out what is the x value. I have the function available to me. So I'm going to replace my y value with 2. So 2 is equal to x to the 5th plus x. A little bit of a trial and get to check here. I'm just going to get that x or 2 over to one side. I'm just going to test a bunch of numbers here. If 0 doesn't work, then I'll try 1. If 1 doesn't work, I'll try -1. So if I try 0, 0 plus 0 minus 2, that doesn't equal to 0, right? It doesn't work. If I plug 1 in, would 1 work? 1 plus 1 minus 2 equals 0. Yeah, that works. So if it works, then we can use that number. So my order pair is 1, 2, and 2, 1. When the function is inverse, there's always going to be that relationship. Now, if I can find f prime of 1, if I can find the slope of the f graph at 1, then this number will lead me to this number, because these numbers will always be reciprocal. Okay, so let's find f prime of x first. So f prime of x. If I can plug 1 in. So what's the derivative of x is plus x? Plus. Okay. Now f prime of 1, plug 1 in for the slope. Find the slope. So if the slope here is 6, then the slope I'm looking for is what? Yeah.
Is there another related in
Mm-hmm. Find another one. Yeah, so anything on page 5, those 4 problems, you can tell me which one you want me to do.
How do I know which one is DR or DS or DS? I somehow, I gotta know what the label is.
Right, so we always start off with some equation, right? It could be Pythagorean theorem, it could be area of a circle, it could be area of a rectangle. We always start with that, and then we go and we find the derivative of that equation.
Okay.
So you want to pick one to do? Three, okay. So three says the base of a triangle is increasing and h is decreasing, which is following is true about the area of a triangle. So we know that we're dealing with the area of a triangle. You see all these mentioned with time, so it's gotta be related right here. So we start off with area of a triangle. What's the area of a triangle? 1/2 base times height. Okay, so if I want to find the derivative of this equation, I have to get dAdt to show up. I got to get dV/dt, dAt to show up. I got to go through what I normally would with derivative rules, right? Now, A is by itself, so A just becomes dAdt. Derivative of A is just 1, just like how x becomes 1, right? Now, this side is a little bit more complicated. These are two variables multiplied together. Find the derivative, I have to go through what? Product rule. So this one, I got to go through product rule. With the sphere and circle, there's no need for product rule because there's no two variables stuck together. If here I have two variables stuck together, so I have to go through a product rule. So that's prime G plus F. Derivative of 1/2 B is what?
1/2.
Yeah, we're going to see what. H doesn't move. 1/2 B is F, and G prime, what's G prime? Yeah, G prime. This is the only calculus step. The rest is just cleanup. So, let me clean this up. dAdt is equal to 1/2 H. It says, if the base of a triangle is increasing at 3 inches per minute, what does that refer to? And positive or negative 3? Positive, so I can replace this with 3, right? The height is decreasing at a rate of 3 inches per minute. This part needs to do that. Okay, so I'm just replacing what they're telling me to replace. I can clean this up here, make it 3/2 H minus 3/2 B. This is as far as we can go. And now, based off of this, we're asking which must be true. A is always increasing. That means dAdt is always positive. Not always true, right? If B is a larger value than H, then it's going to force this to be negative. So we know A is false. A is always decreasing. That means dAdt is negative. dAdt is not always negative, depending on H, right? If H is larger than B, then my adding these two values will give me a positive number. So that's out. A is decreasing, so dAdt is negative when B is less than H. Well, if B is less than H, that means this is a larger value. This will be positive. dAdt is going to be positive, not negative, but B is not negative. A is decreasing only when B is greater than H. So that's true. When B is greater than H, you have a larger negative number than a positive. dAdt will always be negative in B. And then for C, A remains constant. That means dAdt is 0. But dAdt is only 0 if H and B are the same. So we can't guarantee that without knowing what H and B are. So the key thing with related rates, find the derivative like you normally would, but then as soon as we get done with that variable derivative, just attach a d over dt for that variable. Okay, let me know if you have any individual questions. opposite.
Like something I could, yeah, I don't know.
I don't know, I don't have no. But I mean, which part of your peripheral is going?
And, you know, it's just a sign of. Negative one, or whatever, then you have to find, oh, yeah.
So you know, 5 or 3. Look at there. Start with the upper left corner. So we know everything's by 2. Start here and go count 1, 2, 3. And put square over all the numerals. But you square to 1 if you want, so I can do that. And then your order pair is alphabet cosine first. Cosine of 5 of 3 is 1. Cosine of 5 of 4 is 3. Sine of 5 of 6 is 1.
Okay, so it just says like. Yeah.
Yeah. Well, you know that anything with a denominator is going to be just a sign. You have to figure out which quadrant. So here's sine of 5 pi over 6. You know it's going to be related to that. Sine is in the second quadrant. Sine is the y value. You know the y value is always positive. So
And it's like that over 2, or something.
it's over 2. You mean like sine of 3 pi over 2? Or sine of over 2.
So you want me to get on there?
Right. Yeah. If it's divided, then you would want to clean it up. So we're going to do 3 pi over 4. 3 pi over 4, the second quadrant. You know it's got to be related to this number. Still positive because the y value is positive. So yeah, all you know are these numbers, and your calculator can give you some help. You know, root 2 over 2 is 0.707, and root 3 over 2. So if you do cosine of 5 over 4, you'll get 0.707, and you can know these numbers.
I didn't even see that.
Okay.
Thank you.
Yeah, so it says, the rate of increase in the area, so that means the ADP, is equal to twice the rate of increase in circumference. So I know the ADP equals 2 times PCP. Now I'm just going to make a bunch of substitutions. I know the ADT is this. I know PCP is this. If I replace those two, because we built the ADT here. The ADT is the derivative. Pi r squared derivative. 2 pi r. T is that 2 pi.
So circumference is, and we need to know this.
I'll give you the area, but you should know just by the derivative. But on the AP exam, you're going to have to know these.